Hello everybody, thank you for watching. This is 11.4 phase change calculations video. So if you remember from the previous video, this is a phase change diagram for water. In the diagram, we have our solid, liquid, and gas states of matter that is represented in the diagonal section of the graph, and we can see that over here we have a temperature change. In the flat areas right over here, this is where our phase changes occur. So we have a solid that is turning into a liquid and it's undergoing melting, and we have a liquid that is vaporizing into a gas. Whenever we have phase changes, we want to account for that temperature that's not changing. So we're going to have to use this formula where Q equals M delta H, and that delta H can be either heat of fusion if it's undergoing that specific type of phase change, or heat of vaporization. In our diagonal regions right over here, we are using our specific heat formula because heat is adding and our temperature is increasing. Therefore, there's an increase in kinetic energy. So what we're going to do is we're going to go through 3 example problems. The first example problem is asking how much heat is absorbed to completely melt 20 grams of ice at 0 degrees Celsius. So we're going to go ahead and take a look at our phase diagram right over here. And we know that we're starting off with 20 grams of ice at 0 degrees Celsius. So we have ice in the solid form and it's going to melt into liquid. So it's undergoing this phase change right over here. So this is a flat portion where temperature is not changing. So we're going to have to use this equation right over here. And it's going from a solid to liquid. So we're going to use our heat of fusion. The heat of fusion of water is 334 joules per gram. So we're going to use this equation and we're going to plug in the values that we have. Our mass is 20 grams and our heat of fusion is 334 joules per gram. So the only thing that we need to do now is just multiply these two values. And when we do that, we get a final answer of 6,680 joules. So it takes this much heat in order to melt 20 grams of ice at 0 degrees Celsius. In our second example, it's asking how much heat is necessary to heat up to 125.5 grams of ice up to a temperature of 75 degrees Celsius. So what we're having here is we have ice at 0 degrees, so that's the solid form, and we're heating this up to 75 degrees Celsius. So we're going to go through this phase change between a solid and a liquid, and then we're going to heat this up to 75 degrees Celsius. So you can see that we have this area right over here, which is our phase change, and we have this area over here where we have a temperature change. So in order to answer this question, we need 2 formulas. The first formula that we're going to use is to account for this phase change, which is our Q equals M delta H of fusion, because we're going from a solid to a liquid. The second formula that we need is our specific heat formula, because that's this diagonal area over here. We're going to account for the temperature change. So what we're going to do now is we're just going to plug in values for our mass and our heat of fusion, which is given to us in this box right over here. And then we're going to plug in our mass and specific heat and our temperature change into the second formula. The specific heat of liquid water is 4.184 joules per grams degrees Celsius. Right over here, our delta T is our temperature change. So right in this section right over here, we want to go up to 75 degrees Celsius, but we start at 0 degrees Celsius. So that's why our delta T is 75 degrees Celsius minus our 0 degrees Celsius. The last thing that we want to do is we want to add up all these values on both sides of the equation, and then we want to just sum them all together. So when you multiply 125.5 grams with our heat of fusion, you're going to get a Q value of 41,917 joules. And then on the right side, when you multiply all this over, you're going to get a Q value of 39,381.9 joules. The last thing that you need to do is add these two values together to get our final answer of 81,298.9 joules. Our last example problem is asking us how much energy is necessary to turn 50 grams of ice at negative 5 degrees Celsius to steam, which is going to be a temperature of 105 degrees Celsius. So looking at this phase change diagram, we can see that we're starting at -5 degrees Celsius and we want to go all the way up to steam that is 105 degrees Celsius. So we're undergoing temperature changes and also phase changes. So we need to use the formulas accordingly. So we're going to start off with this area right over here. We have a temperature change from -5 degrees Celsius all the way up to 0 degrees Celsius. So we need our specific heat formula for that. So we're going to start by using that formula, and then right over here we have a phase change where we don't have a temperature increase. So we're going to have to use our phase change diagram right over here. We're undergoing melting, so we're going to have to use heat of fusion. We're going to add that together with our temperature increase from going from a 0 degree liquid all the way up to 100 degrees where we're going to boil. So what we're going to do is we're going to use our specific heat formula for that. Then lastly we have our phase change right over here where we have liquid water at 100 degrees Celsius and we're vaporizing it to a gas. And then finally we have our temperature increase from 100 degrees Celsius all the way up to 105 degrees Celsius. What we want to do now is we want to plug in all these values. So if you look at this box right over here, we have a specific heat of ice, which is this value. We have our heat of fusion, we have our specific heat of liquid water, we have our heat of vaporization, and we have our specific heat of water vapor. So you want to plug that in accordingly. So we're going to start by plugging in our mass and specific heat of ice and our temperature change from 0 to -5. We're going to plug in our mass and heat of fusion. We're going to plug in our mass, specific heat of water, and our temperature change right over here. And then we're going to account for our phase change from liquid to gas. And then lastly, we're going to plug in our values for the specific heat of water vapor. Then what you want to do is you just want to multiply everything and get your Q values. So when you do this equation, you're going to get a Q value of 515 added together to a Q value of 16,700, and then you're going to add this together. You're going to multiply this over, and then you're going to multiply this over. The last thing that you need to do is add up all these Q values together to get your final answer. And when you do that, you're going to get a final change in heat, which is going to be 151,642.6 joules in order to take ice from -5 degrees Celsius and turn it into steam at 105.